very easily. But it actually does relate to this panel, and I thank you for being here. If I may begin by looking back a bit, in 1851, a revolution in medicine already underway was crystallized in a letter Louis Pasteur wrote to a friend. I'm on the edge, he said, of mysteries, and the veil is getting thinner and thinner. Thanks to the work of Pasteur and succeeding generations of scientists, mysteries of the microbial world have slowly been revealed, and we're all a lot healthier and living a lot longer as a result. Childhood diseases like polio and measles have in many ways been vanquished. Scientists were able to identify the AIDS virus, which helped lead to treatments, and according to one of our witnesses today, the real possibility of a cure for AIDS is in sight. The last global pandemic that killed on a massive scale, the Spanish flu pandemic, killed at least 50 million people, was almost a century ago. I remember this because it deprived me of ever knowing one of my grandmothers, my paternal grandmother, who died as a young woman in New York in that pandemic. But in addition to all the medical miracles that were underneath that veil, Pasteur began to peel back. There were, of course, also dangers. Research that can lead to cures extending life for millions also can kill many if a rogue pathogen were released either by accident or because it fell into what I will call evil hands. And it is this paradox of dual-use research that we gathered together today to consider at this hearing. Last fall, the world was shaken by the news that two researchers research teams really working independently had been able to engineer a new strain of the H5N1 virus, which we know as bird flu, that could easily infect humans. Epidemiologists have long feared that if the H5N1 virus ever made the jump from a virus mostly confined to birds to one easily transmitted among humans, it could swiftly cause a pandemic. The mortality rate for the few reported cases in humans who have been infected is as high as 60%. By contrast, the Spanish flu, which I mentioned earlier, had a mortality rate of about 2%. The researchers that I refer to, based both at Erasmus University in the Netherlands and the University of Wisconsin, announced that they were going to publish the results of their studies in the journal Science and Nature. This set off what I would call a global ethics debate in the scientific community about whether to publish or not publish these results, and if the experiments, which were funded by the NIH, should have been undertaken at all. On the one hand, there are those who say that getting this information out could help other scientists better understand the mutant strain so they could prepare for a possible pandemic by investigating, looking for natural mutations and developing vaccines and medications. The fact that these two research teams were able to create this new strain from existing genetic material means that nature could create it as well. In fact, many scientists said that that was quite likely. But given the lethality of the virus, others argued that publishing the results would create huge security risks because it would offer a blueprint for a deadly biological weapon to rogue states or terrorists. And of course, that's where this committee's interest is joined because of our responsibility for Homeland Security. In a recent speech at a biological weapons conference in Geneva, Secretary of State Clinton warned that al-Qaeda in the Arabian Peninsula had in fact issued a call for, I quote, brothers with degrees in microbiology or chemistry to develop a weapon of mass destruction, end quote. And of course, there's also a danger that the manufactured strain might somehow escape, so to speak, from the laboratory, which is something we've worried about in the past. Last December, at the request of the Department of Health and Human Services, the National Science Advisory Board for Biosecurity, or NSABB, was asked to review the H5N1 research papers. The NSABB concluded that more needed to be known before the research was made public and They asked the editors of Science and Nature to delay publication. Both magazines agreed. Last month, after further review, the NSABB withdrew its objections and voted unanimously to allow the University of Wisconsin study to be published, and by a divided vote of 12 to 6 to allow the Netherlands study to be published with some revisions and clarifications. One of the things that apparently influenced the board's decision was the revelation that the modified strains of H5N1 had become less lethal. But as the members of the panel know, I'm sure, that decision has drawn criticism from Dr. Michael T. Osterholm, director of the Center for Infectious Disease Research and Policy at the University of Minnesota, and an NSABB board member himself. In a letter to the NIH, he wrote that the NSABB had deliberately ignored the voice of scientists who believed publication of the H5N1 research was dangerous. And I quote from his letter, "I believe there was a bias toward finding a solution that was a lot less about a robust science and policy-based risk-based analysis, risk-benefit analysis, and more about how to get out of this difficult situation." He then added, "We can't just kick the can down the road without coming to grips with the very difficult task of managing," and I know he was referring to dual-use research. End of quote. So this is a serious charge, which I hope as the morning goes on, the panel will respond to. The publish or not published debate continued earlier this month during a two-day conference of the world's leading scientists convened by the Royal Society in London. One point I learned that most of the attendees seem to agree on is that we need to put in place better systems to track this kind of research at each experimental stage, rather than waiting until it's ready for publication to make decisions about what can be revealed. And that's another question that I hope our panelists will discuss today. Although this particular controversy about publication appears to have been resolved, it's going to recur. And as Osterholm said, we can't just kick the can down the road and deal with it on an ad hoc basis. What systems were in place to monitor dual research that could produce dangerous results at the time these experiments were begun? What new systems are being put in place now are more needed? And how do we balance these against our obvious valuation of the and valuing of the quest for knowledge, of free scientific inquiry? Etched into the National Academy of Sciences headquarters wall are the words of Einstein, one of many words that are quoted often of Einstein. The right to search, the right to search for truth implies also a duty. One must not conceal any part of what one has recognized to be true. End of quote. But of course, this matter before us this morning raises another question that's relevant, which is what if peeling away nature's veil, in Pastor's term, unleashes dangers to the world? Those are difficult questions to balance, and again I repeat that we ask them here in this committee because of the direct connection between this scientific work and the homeland security of the American people, which it is our first responsibility to protect. I really look forward to your testimony and the question and answer period. And again, thank you for being here. Senator Collins.
Thank you, Mr. Chairman. It has been almost a century since the 1918 Spanish influenza virus infected 1/5 of the world's population, killing more than 50 million people and claiming some 600,000 American lives. Yet virulent strains of influenza are still a major threat. The H1N1 strain, more commonly known as the swine flu, claimed more than 18,000 lives during the 2009 outbreak and exposed gaps in our preparedness capabilities for response to a global pandemic, especially in the development, production, and distribution of life-saving vaccines. In 2008, this committee held a hearing on the report by the Commission on the Prevention of Weapons of Mass Destruction, which examined the security of biological pathogens on the select agent list. The testimony by the chairman of the commission, former Senators Bob Graham and Jim Talent, helped to raise awareness on the issue of biosecurity and the need to ensure that deadly pathogens and the research carried out on them are contained in secure lab facilities. This committee has also held numerous hearings on the nation's efforts to prevent, prepare for, and mitigate the impact of a pandemic influenza outbreak. In 2009, the administration's failure to ensure that the government was prepared to rapidly distribute vaccines was and remains a cause for great concern. Preparedness also requires investing in critical life sciences research to expand our knowledge base and technologies to help us better respond to the next potential global pandemic. Such a pandemic could be even more communicable than the 1918 influenza virus or as virulent as the avian flu virus. The World Health Organization has documented 576 human cases of avian flu infection worldwide since 2003. 339 of those cases resulted in death. Recently, research funded by the National Institutes of Health and conducted in Wisconsin and the Netherlands resulted in genetic changes to a strain of avian flu that allowed its airborne transmissibility. The NIH-funded researchers plan to publish their full findings in 2 academic journals. Now, publication, peer review, and replication of findings are obviously important steps in a vigorous scientific process. But others have expressed concern that the publication of the methodology and some of the data could help create a roadmap for terrorists and others seeking to further modify the virus into a bioweapon. That's why a government advisory board, the National Science Advisory Board for Biosecurity, recommended in late December that partial information be withheld from publication. Late last month, however, the board, with some dissenters, reversed course and is now advocating for the full publication of research done in Wisconsin and the publication of a revised paper on the research performed in the Netherlands. The decision and its reversal have been part of a larger debate within the scientific and national security communities, and there are important arguments being made on both sides. When the American people pay for scientific research intended for the common good, they have a right to expect that their money will not be used to facilitate terrorism. These are not hypothetical threats. Before he was killed, Anwar al-Awlaki reportedly sought poisons to attack the United States. Adding to these concerns, the new leader of al-Qaeda has a medical background. Therefore, he may have an even greater interest in pursuing chemical and biological terrorism. At the same time, there is a legitimate concern about government censorship that could chill academic freedom and scientific inquiry, or even limit the sharing of information necessary to save lives or improve public health. Recently, NIH released a new policy for the oversight of dual-use research of concern. This policy is intended to improve our awareness of current and proposed dual-use research of concern and provide some guidelines for mitigating the associated risks. This new policy, however, is only the beginning of what must be a straightforward dialogue among science, health, national security, and government experts and leaders in order to promote scientific research while protecting the safety of Americans and others around the world. I look forward this morning to hearing and reviewing the testimony of our witnesses about these challenging issues and how we can strike the right balance. I do want to apologize that I will, however, have to leave early due to a markup in the Appropriations Committee that begins at 10:30, but I will certainly review the transcript of this hearing. Thank you, Mr. Chairman.
Thank you, Senator Collins, for that thoughtful statement, and I'm sure whether it's at this particular meeting, appropriations, or others, you'll be watching out for the budgets of NIH, DHS, and others that may be recipients on the panel.
Absolutely.
Thank you. That's your record, I know. Our first witness is Dr. Anthony Fauci, really a national hero, at least a hero of mine. And I'm sure others, Director of the National Institute of Allergy and Infectious Diseases at NIH. I really appreciate that you're here today, and we look forward to your testimony now.
Thank you very much, Mr. Chairman. Senator Collins, thank you for the opportunity to testify today on the NIH mission of performing biomedical research for the purpose of preparing for and responding to naturally emerging and re-emerging infectious diseases and the relationship of this type of research to biological security. As you mentioned in your statement, the issue at hand is the ongoing threat of the emergence of an H5N1 pandemic influenza and the research that was supported by the NIH to address this threat. The conduct and publication of the results of such research in the form of the two manuscripts that you mentioned has focused considerable public attention on the issue of dual-use research, namely research that is directed at providing new information critical to the public health, but at the same time has the potential for malevolent applications. My written testimony is submitted for the record, and in my few minutes of time, I will highlight just a few important aspects of this issue. First, the public health challenge. Seasonal influenza is an ongoing threat to public health worldwide and is among the leading global causes of death due to infectious diseases. Each year, influenza causes more than 200,000 hospitalizations and up to 49,000 deaths in the United States and up to 500,000 deaths globally. Yet influenza has animal reservoirs, especially in birds, and these viruses can undergo extensive genetic changes and jump species, resulting in an influenza virus to which humans are highly vulnerable. Such an event can, and historically has, led to global disasters, such as the one you mentioned, the prime example being the 1918 global influenza pandemic that killed up to 100 million people worldwide and caused enormous social and economic disruption. There is a clear and present danger that we will have another pandemic, since these viruses continue to circulate in the world and are constantly evolving towards pandemic capability, as we have seen in 1957, 68, and 2009. Over the last decade, a highly pathogenic H5N1 influenza has emerged among chickens. Rarely, the virus spreads to humans. Since 2003, approximately 600 confirmed cases have occurred in humans in more than a dozen countries shown in red on this poster. Nearly 60% of those reported cases have resulted in death. Should the virus mutate to transmit more efficiently to and among people, a widespread influenza pandemic could ensue. Indeed, nature itself is the most dangerous bioterrorist, and even as we meet today, H5N1 and other influenza viruses are naturally mutating and changing with the potential of a catastrophic pandemic. This is not a theoretical danger. It is a real danger. For decades, NIH has supported basic influenza research included on transmissibility, host adaptation, and virulence. The goal is to anticipate what the virus is continually trying to do on its own in the wild and to prepare for it. Such goals were pursued by the NIH-funded scientists Kawaoka and Fauci and could have important positive implications for pandemic influenza prediction, prevention, diagnosis, and treatment. Kawaoka and Fauci constructed variants of H5N1 avian influenza in order to identify which genetic mutations might alter the transmissibility of the virus. In their studies, they employed a standard influenza animal model, namely the ferret. This slide shows the basic design of the experiments in which the virus was modified to allow for aerosol transmission from one ferret to another. I might point out that one of the causes of the public misunderstanding was the widespread belief that the virus that was transmitted by aerosol from one ferret to another actually killed the ferrets, when in fact that was not the case. We feel that these studies provide critical information, and it was important to determine if H5N1 virus that has this enhanced transmissibility would remain sensitive to existing anti-influenza drugs and vaccines. In addition, and importantly, knowledge of the genetic mutations that facilitate transmission may be critical for global surveillance of emerging influenza viruses. Yet, since transmissibility of a virulence virus was increased, this constitutes dual-use research of concern, or DIRC, which is shown on this poster. If a particular research experiment is identified as DIRC, that designation does not necessarily mean that such research should not be published, nor that it should even be prohibited in the first place. However, it does call for us, as you mentioned, to balance carefully the benefit of the research to the public health, the biosafety and biosecurity conditions under which the research is conducted, and the potential risk that the knowledge gained from such research might fall into the hands of those with ill intent. In this regard, the National Science Advisory Board for Biosecurity, or NSABB, was asked to advise the United States government on the publication of these manuscripts. You will hear in detail from Dr. Keim, the chair of that group, about the board's deliberations. Importantly, the public attention and concern generated by this issue has triggered a voluntary moratorium or pause on this type of research on the part of the influenza research community, as well as a fresh look at how the U.S. government handles DIRC as manifested by a formalization of a government-wide policy to address the issue. This policy, which was released on March 29th, strengthens and formalizes ongoing efforts in DIRC oversight and is described in my written testimony. The ultimate goal of the NIH in its embrace of this new policy is to ensure that the conduct and communication of research in this area remain transparent and open at the same time as the risk-benefit ratio of such research clearly tips towards benefiting society. The public, which has a stake in the risks as well as in the benefits of such research, deserves a rational and transparent explanation of how these decisions are made. The upcoming dialogue related to this policy certainly will be informative and hopefully productive in its goal of benefiting the public with the fruits of such research while ameliorating the associated risks. Thank you.
Thanks very much, Dr. Fauci. That was an excellent introduction to the topic, and I look forward to asking you some questions. Next, Dr. Daniel M. Gerstein, Deputy Undersecretary for Science and Technology at the U.S. Department of Homeland Security, obviously sharing with the committee the concern about whether this research represents a real threat to our Homeland Security, and if so, what we should do about it. Thanks so much for being here, and we welcome your testimony now.
Thank you. Well, good morning, Chairman Lieberman, Ranking Member Collins. I thank you for the opportunity to testify today regarding dual-use life science research of concern. My testimony today will describe both Department of Homeland Security mechanisms for addressing and mitigating dual-use concerns arising from internal life sciences research that DHS funds or performs, as well as DHS involvement in U.S. government and other efforts to address security concerns arising from the life sciences research. As the Department considers the DIRC issue, several principles help guide our thinking. First, DIRC is an extremely complex issue for the scientific research and development community, balancing our nation's need to excel in science and exploration of robust technologies with ensuring our nation's security by preventing the misuse of such technology. Second, almost all research conducted today in bioscience and biotechnology contains some degree of dual-use application. Third, dual-use concerns must be addressed at a variety of different levels, from research funded by governments to research funded privately to experimentation done by individual scientists. And finally, there are both domestic and international dimensions to the DIRC issue, as the recent H5N1 papers have clearly demonstrated. DHS performs research which might be considered DIRC through a variety of different mechanisms, including our internal laboratories, such as the National Biodefense Analysis and Countermeasures Center, NBAC, and Plum Island Animal Disease Center, PIADEC. We also sponsor and collaborate with other departments. Additionally, we provide funding to colleges and universities, primarily through our DHS Centers of Excellence program. One vignette that demonstrates the degree to which dual-use research is both ongoing and critical to the DHS mission is the development of a recombinant foot and mouth disease vaccine. The recombinant vaccine components are being developed through our DHS Center of Excellence at Texas A&M. The material is then shipped to Plum Island, where it is used in challenge tests employing live FMD virus. At Plum Island, DHS and United States Department of Agriculture are working shoulder to shoulder in this effort. Once approved for licensure, a commercial company will produce the vaccine. This cross-cutting project demonstrates the importance of collaborative efforts in dual-use research. DHS's primary objective in funding activity in the life sciences is to meet our Homeland Security mission. We therefore exercise control of the information where necessary through non-publication or non-disclosure mechanisms. Research conducted or funded by DHS in the areas of biological and chemical defense undergoes particular scrutiny and high-level departmental review because of the potential to raise concerns regarding security, non-proliferation, and treaty compliance. At DHS, our approach to dual-use research is multidimensional. At the lowest levels, project managers are trained to understand and assess their programs for possible dual-use implications. The National Science Advisory Board for Biosecurity, NSABB, definition of DIRC, embodied in the NSABB 7 experiments of concern, serves as the basis for this understanding. These same criteria have been identified for use in the new federal-wide DIRC policy. The DHS Compliance Assurance Office, or CAPO, reviews projects that are to be conducted. This review divides potential projects into tiers based on whether they include NSABB experiments of concern, raise perceptions of noncompliance with arms control agreements, utilize select agents or toxins, have the potential to generate or reveal national security vulnerabilities, or provide information on threat agent production or dissemination. At the highest levels of the department, our Compliance Review Group, or CRG, chaired by our Deputy Secretary, with full participation across the staff, reviews all DIRC with a particular eye towards ensuring compliance with Chemical Weapons Convention and Biological Weapons Convention, BWC. DHS routinely contracts for life science research that involves use of select agents and toxins or that require special biosafety provisions. In all cases, we ensure that contracts contain clauses to ensure conformity with applicable laws, regulations, and internal policies. In addition, research contracts for life sciences work typically provide for DHS to object to publication or disclosure. Further, depending on the type of proposed publication or disclosure, the information to be released must go through an internal review process. In the unlikely event that sensitive or classified material is produced from research projects funded through grants to academia, DHS requires grant recipients to create information protection plans which detail how the information would be identified and secured. Now, I've been discussing the internal management of DIRC within DHS. Let me now turn briefly to the broader DIRC issue. DHS has been an extremely active participant in the formulation of the U.S. government policy on the dual-use research, including the 29 March government policy for DIRC oversight. We are in complete agreement that strengthening DIRC oversight and establishing regular reviews of U.S. government-funded or conducted research is both necessary and a responsible approach. However, even with the kind of internal DHS oversight policy described previously and the U.S. government-wide policy on oversight of U.S.-funded life sciences research, DHS believes that security-related concerns to DIRC cannot be entirely resolved by formal U.S. government policies. The international nature of life sciences research, coupled with the explosion in biotechnology funded by private sources, means that much of the DIRC being conducted is not under direct U.S. government control. Advances in the life sciences will undoubtedly create technological capabilities that will be of tremendous benefit to humankind, but will also require careful stewardship, including development of appropriate regulations and policies, as well as continued emphasis on strong biorisk management programs that emphasize biosafety, biosecurity, and bioethics. In working through this issue, we must find ways to mitigate risks associated with the potential malicious use of DIRC, while at the same time allowing for open and unfettered innovation by our nation's scientists and laboratories. At the end of the day, the DIRC issue comes down to a risk-benefit evaluation of whether the balance is in favor of sharing the information for the good of humankind for public health, medical, or biotechnology advancement versus the potential for misuse. Ultimately, the international life sciences community must appreciate the DIRC problem and internalize these concerns while developing and conducting research. In this regard, the H5N1 papers have served as a necessary wake-up call for the life sciences community. Thank you for giving us the opportunity to testify today, and we look forward to your questions.
Thanks, Dr. Gerstein. Just while we have you and while it's on my mind, clarify for the record and for me what the role of the Department of Homeland Security is with regard to dual-use research happening outside of DHS grantees.
Well, Senator, we sit as part of the interagency body that deliberates, and so we have a strong voice. And in fact, as I'm sure we'll talk more about later, the 29 March policy actually reflects much of the work that we have been doing previously in fulfilling our Biological Weapons Convention requirements. We made use of the NSABB 7 experiments of concern. We've always looked at the select agent program to make sure that we are in accordance with the requirements and the reporting requirements. So we do that tiered process in order to make sure that experiments do full compliance with the BWC. What we've done, though, is that because of the alignment of the 29 March policy and the work that we have done previously, we essentially have a leg up on the implementation of the 29 March policy.
Okay, and just to take this one step further, and the board on which you sit, is this to determine government-wide policy or also to approve particular projects or to evaluate particular research projects?
These are internal boards that are designed to look at the department's experimentation, the projects that we're to be conducting.
Okay, and then finally, just give us a sense, and I don't think you have to get into too much detail here, about how widely dual-use research projects are being carried out or funded in the federal government. In other words, the natural place to think about is NIH, but I presume DOD is also doing funding projects, et cetera.
Well, so Senator, I'd like to stick to my department and just tell you what we're doing in the Department of Homeland Security. We, through our review process, our compliance review group, looks at a total of about 200 projects that fall into what we call Tier 1, just regular experiments that don't rise to the level of concern. In the Tier 2, ones that could perhaps have some issues with perception, we do 12 to 15, and then in the highest category, we do 5 to 10. So a total of about 225 experiments per year, of which all of them run through our compliance review group process.
And those are all funded within DHS?
They are, yes.
So maybe, Dr. Fauci, you're the one to turn to give us, for the record, a kind of broader sense of how widely dual-use research is either being done or in federal agencies or funded by federal agencies.
So that's a very good question, Mr. Chairman. And it's important, as you did yourself, distinguish between dual-use research and dual-use research of concern. Almost any time you even go near a microbe, it's dual-use research. If you're talking about dual-use research of concern, we actually, just for this purpose, as part of the implementation of the March 29th government-wide policy, we did an inventory of what we do both with our own scientists at the NIH and at the NIH-funded government scientists, as well as the external extramural grantees and contractors. And just to give you some example, when we did an inventory of what we do mostly on a Bethesda campus and in our Rocky Mountain campus, there were 404 intramural projects that could be dual use, plus 147 manuscripts, and none were found to be dual use research of concern. When we did the extramural inventory of all of the grantees, there were 381 grantees or contractors. 10 of those grants were designated as DIRC. 7 of them were in influenza, 1 in anthrax, 1 in plague, and 1 in botulism. So out of 381, there were only 10. And those are the ones we're now going through the process that's delineated very carefully in the new policy. So that's the scope of what we're doing at NIH.
Okay, that's very helpful. And just generally, am I right to assume that there may be dual-use research projects of concern, for instance, at the funded by the Department of Defense?
As Dr. Gershon, I'd hesitate to make a statement about the Department of Defense, but we collaborate a lot with them. And yes, I cannot imagine that they're not doing some, but probably a really small amount. But they clearly are doing some.
Okay. So most is probably coming through NIH. Okay. Thanks very much. Next, Dr. Paul Keim, Acting Chairman of the aforementioned National Science Advisory Board for Biosecurity. We thank you very much, Dr. Keim, for being here, and please proceed with your testimony now.
Chairman Lieberman, thank you for holding this hearing on biological security, the risk of dual-use research. I am Paul Keim, the Acting Chair of the National Science Advisory Board for Biosecurity. I appreciate the opportunity to speak to you about dual-use research, and in particular about the Board's activities and our recent evaluation of 2 scientific papers concerning the avian H5N1 influenza virus. It's been recognized for many years that science and technology can be used for both good purposes and bad. It is this two-sided coin that we refer to as dual-use research. The problem is that all biological research can be construed as having potential bad applications as well as their good ones. The NSABB created a new term, dual-use research of concern, or DIRC, as we've been saying, to distinguish normal research from that with exceptionally high potential to be misused. The parameters defining DIRC would include the magnitude of any danger and the immediacy of any threat as balanced against the overall benefits of the work. Over the last 8 years, the Board has advised the U.S. government on best practices and policy approaches for research communication, personnel reliability standards, codes of conduct, and international engagement for issues associated with DIRC. The Board has recognized that good policy needs to protect us from scientific misuse and protect the scientific enterprise from being overburdened with unnecessary regulation. Both are essential for our country to be safe, productive, and to remain a global leader. The National Science Advisory Board for Biosecurity is comprised of well-respected scientists, lawyers, infectious disease experts, scientific editors, and public health experts. We have an 8-year track record of protecting academic freedom while seeking policy recommendations that will minimize the misuse of biological sciences research. With that in mind, recognize the significance for the Board to unanimously recommend against the publication of 2 scientific papers in November of 2011 due to their potential to be misused. The U.S. government asked the Board to review 2 NIH-funded studies reporting mutations that allowed a highly dangerous bird flu virus to transmit from one ferret to another. By a split vote, the Board instead recommended to the government that key elements of the studies not be published and that only redacted papers were acceptable for general distribution. These recommendations were based upon the board's finding that if this avian influenza virus acquires the capacity for human-to-human spread and retained its current virulence, the world could face a pandemic of significant proportions. We found that the potential risk for public harm to be of unusually high magnitude. The board has published its recommendations to the U.S. government along with its rationale. Importantly, we pointed out that an international discussion was needed amongst multiple societal components to develop policy in this arena of high-consequence DIRC. I would further note that in the few months since our recommendations were released, there's been a flurry of U.S. and international meetings to discuss the risks and benefits of these experiments. The research, issues, and policy consequences are now commonly known and being debated. This continuing global conversation is important for the scientific endeavor and for our biosecurity. In late March 2012, the U.S. government tasked NSABB with reviewing revised versions of the two original manuscripts. This was coupled with a face-to-face meeting such that the board could hear directly from the investigators about their research. In this meeting, the board received non-public information about the risks and benefits of the research from the international public health and research community, as well as from the United States government intelligence community. In a classified briefing from National Intelligence Council and National Counterterrorism Center representatives, the board heard an assessment of the risk for misuse and of the global political ramifications associated with these papers. The details of these briefings are classified, but I can tell you that many of the board were left with the impression that the risk of misuse did not appreciably increase with full publication, and there is a high likelihood of undesirable political consequences to not publishing. In addition, the U.S. government has recently issued new policy guidelines targeting high-consequence DIRC. This was based upon the NSAB's own definition of DIRC and 7 categories of experiments that warrant special consideration and targeting particular high-consequence pathogens. It is in this context that the board arrived at different recommendations for the revised manuscripts. One paper was unanimously recommended for full publication, while the other was recommended by a split vote of 12 to 6. In balancing the risks against the benefits of the revised manuscripts in the context of additional information and new U.S. government policy, the board shifted its position. In my opinion, this split vote is highly significant and signals that the board still believes that there is great potential for misuse of information generated by these types of experiments. The majority of the board members voted for publication, but they were clearly still troubled by this research and its potential to be misused. It is fair to say that the board believes that these types of experiments will arise again and that these issues are not fully settled. As one board member noted, we've only kicked this can down the road and we'll be dealing with it again in the future. It is critical that we establish policy that intensely monitors high-potential DIRC research from cradle to grave in order to protect us from misuse, but also to free low-potential DIRC research from onerous regulations. We must be careful that we don't destroy the scientific enterprise as we try to protect against the misuse of some research. Thank you.
Thanks very much, Dr. Keim. Let me just ask you while the phrase is in my mind. What did you mean when you said we referred to undesirable political consequences from not publishing?
Well, so this was in the classified briefing, and so in this environment we can't talk about it in detail, but there are many international collaborative projects going on in public health to try to control and predict and understand influenza pandemics. Many of those political agreements are very fragile, and I think that it's fair to say that not releasing this information was seen as having a detrimental effect upon those fragile relationships.
Okay, thank you. Final witnesses, Dr. Thomas Inglesby, Chief Executive Officer and Director, Center for Biosecurity, University of Pittsburgh Medical Center. Welcome back.
Mr. Chairman, thank you for the chance to speak to you today. My name is Tom Inglesby. I am the Director for the Center for Biosecurity of UPMC. I'm an infectious disease physician by training, and over the last 2 decades, I've seen many patients with influenza die despite excellent medical care in American hospitals. For many years, my center colleagues and I have been studying avian and pandemic flu and the public health actions that need to be taken to protect us from those challenges. And like all of you, I am deeply concerned that H5N1 is a major global threat. I've been opposed to the publication of the revised Fauci manuscript. The breakthrough in that work was making H5N1 transmissible through the air between ferrets. But just as wild-type H5N1 kills ferrets when instilled into their tracheas, this engineered virus also kills ferrets the same way. So there's no evidence that I've seen publicly presented that this engineered virus would have less virulence in humans than wild-type H5N1 infection would. Were this virus to cause a human infection, it could acquire new unpredictable virulence properties. So if this work were replicated after publication, and if it led to human infection following accident or misuse, we can't rule out the chance that it would lead to high case fatality and a spreading epidemic, difficult to stop with quarantine, vaccine, or antivirals. As you noted, there are others in the scientific and public health communities who share this concern. That said, I appreciate that a deliberative process has taken place in the last 6 months. The majority of NSABB members, U.S. government agencies, and the journal Science have decided that this work should be published. I'm concerned about this, but I recognize this decision has been made. So now it's time to look ahead and anticipate the future of H5N1 mammalian transmissibility research, which scientists are now poised to pursue. Here are some brief thoughts on benefits and risks of further pursuing this line of research. Will further engineering H5N1 mammalian transmissible viruses help improve surveillance? In my view, in the short term, it's unlikely. Genetic mutation data is not widely collected in avian flu surveillance systems. Very few sequences are analyzed in real time. Even if we could identify experimental mutations in birds in real time, the prescribed response would still be the same: culling of infected birds, all flocks, regardless of the mutations of the virus. Until we have a surveillance system in place that collects far more genetic sequence, does so in time frames that are meaningful, and have predictive value sufficient to lead to additional action in the field, this research seems unlikely to practically improve surveillance. Nor is this research necessary to making H5N1 vaccine for reasons I explain in my written testimony. What could go wrong with mammalian transmissible H5N1? Could an accident occur? Biosafety at modern labs is generally excellent. Accidents are uncommon and most pathogens have little capacity for societal spread. But the accidental escape of an engineered mammalian transmissible H5N1 could result in catastrophe. Although it's uncommon, accidents do happen. In 1977, H1N1 caused a mini-pandemic, probably from a lab escape. 9 years ago, during SARS, there were at least 3 incidents in which researchers working in BL3 or BL4 labs in Singapore, Taiwan, and China accidentally infected themselves with SARS. I'm not meaning to single out laboratorians for criticism. Mistakes are made by all types of professionals: doctors, pilots, rocket scientists, all of us, because we're human. We have to factor the possibility of human error, surprise, and accidents into our calculations of the risk of this research. Can we assure this research won't be replicated and deliberately misused? No. We can hope no potential adversary will have the competence or the intention to pursue this, but we can't accurately predict the chances this work will be replicated by a malevolent or disaffected scientist somewhere in the world, or a terrorist group, or a nation state. What happens if a mammalian transmissible H5N1 starts to spread? Seasonal flu infects 10 to 20% of the world every year, as much as 1 billion people or more. The case fatality rate of wild H5N1 in the WHO database is nearly 60%, as you indicated. So if a strain of H5N1 with that fatality rate were engineered to spread like seasonal flu, hundreds of millions of people's lives would be at risk. Even a strain 100 times less fatal would place at risk millions of people's lives. So what should be done about H5 mammalian transmissible research going forward? First, I would extend the moratorium that Dr. Fauci discussed. The reasons many experts agree with the moratorium are still valid. Before proceeding, we should have more confidence this research will lead to practical benefits, and we should look for other ways to study transmissibility that don't require engineering mammalian transmissible strains. If this work is allowed to continue, we should limit it to the smallest number of labs. My understanding is that the UK and Canada have indicated their concern by deciding this work can only be performed in BL4 labs. We should have these discussions in an open, transparent way that includes the scientific and public health communities. Second, let's decide if there are red lines that shouldn't be crossed. For example, should increased lethality be engineered into mammalian transmissible strains in order to understand virulence? Should other avian flu strains be engineered for mammalian transmissibility? Should transmissible H5N1 strains be engineered to make them resistant to vaccines or antivirals so we can understand the genetics of those problems? We should decide now if there are any uncrossable lines. And third, the U.S. should continue to strengthen its pandemic preparedness efforts. Priorities should include the capacity to manufacture flu vaccine on a large scale, universal flu vaccine, new antivirals, and better surveillance and culling of infected flocks. Preparing for pandemic and avian flu is critically important. Let me turn to the policy for dual-use research of concern recently announced. This policy is a good step towards addressing the kinds of issues raised by the H5N1 controversy. The success of the policy will depend on how it's implemented. In my written testimony, I provide recommendations for success of the policy, and I'll highlight 4 of them here. Number 1, implement effectively at the local level. Scientists, their institutions, and their institutional biosafety committees will be crucial to the success of this policy. This is new territory for them, so training and education will be key. They'll also need new members, new resources, and a clear process for elevating concerns. Number 2, learn from experience. This process will need to evolve as we learn. I understand that the NIH review of the portfolio found that 10 experiments warranted further risk management. It'd be a valuable learning tool for the science community to understand these 10 cases. What caused the concerns? How were risks mitigated? I think this could be done in a de-identified way to protect the scientists. It'd also be useful to learn as much as we can from the H5N1 risk assessment and risk management process. How were risks assessed? How were conflicts of interest managed? How did the process ensure all relevant judgments were considered and data seen? Going forward, the success of the DIRC policy will depend on these issues. Third, attend to the regulatory burden. This new policy will add another process to be navigated by a scientific community that's already heavily regulated. We have to make sure we don't impose such a regulatory burden that scientists can't continue their important work. And so to this end, I'd recommend asking the national academies to examine the effects of existing policy and regulatory burdens on U.S. scientists. And last, reaffirm the role of NSABB. It deserves a lot of credit for its work. NSABB members have done substantial public service. They've prepared valuable dual-use guidelines and spent a great deal of energy, intellect, and time on this H5N1 debate. An independent and strong NSABB should have an important role in DIRC policy implementation going forward. And I hope that the NSABB will rarely be in the position of getting invited into the process after manuscripts have been submitted. I think we all agree in this room the risk assessment and management process should happen early in the research process. So to conclude, scientists who research influenza and other infectious diseases are working to improve our understanding of biology and to better the world. The U.S. needs to continue supporting entrepreneurial and talented scientists with the best ideas. At the same time, we need to acknowledge there are rare situations where the consequences of an accident or misuse are so serious that special processes are needed to manage the risk to the public. And this new DIRC policy is a good step in that direction.
Thanks, Doctor. Help us just, because lay public, including me, when we hear about accidental escape of pathogens from laboratories, we get alarmed. So is that, talk a little more about it. Does that normally happen because of the example you've stated of infection of workers or personnel in the labs? Yeah.
Yes, in all the cases that I mentioned, in other cases, that is typically the way that an infection would escape a lab, and a laboratorian would get infected. Usually when laboratorians are infected, though, they don't spread it to anybody else.
Right.
So the risk really is primarily to the person working in the laboratory. It's rare for the laboratorian to pose a risk outside the lab.
Right. And Dr. Fauci, I assume that all the regulations, both before and after March 29th, were intent on limiting the possibility of exposure to personnel.
Definitely, Mr. Chairman. In general, definitely, and specifically in the 2 cases that we're discussing as prototypes here today, the 2 laboratories, one in Wisconsin and one in Erasmus, were very, very highly qualified, inspected multiple times, and given a rating of meet or exceed the standards for the kinds of protection we're talking about.
Good. Dr. Keim, let me ask you first about the 2 laboratories that were the subject of this concern. To the extent that you can, why was the ultimate decision unanimous in the case of Wisconsin and then mixed in the case of Erasmus?
So the underlying science and approach that they took for doing these experiments was different. They get lumped together a lot, and so one of the approaches was viewed as having a greater biological control of the risks. It's one of the aspects that we have instituted across the board in biosafety experiments in the United States, which is to try to do these experiments in a biological context that would be less dangerous. And so, for example, if we do an experiment where we're going to add a gene to something, usually we like to do that with a pathogen that has been disarmed or attenuated before we ever get there. And so distinguishing the two groups and their approaches, I would say that was the biggest difference is one worked in a platform, if you will, that was viewed as less risky, not as virulent than the other one, which was taking really the wild type, the raw material from nature, and then changing the transmissibility on that platform.
And if I understand, that difference had more to do with the scientific decisions of each team as opposed to differing levels of safety standards that they were operating under in their respective institutions or countries.
Yeah, so as Dr. Fauci pointed out, both institutions were heavily regulated, heavily reviewed, and both exceeded the requirements for biological safety that we have in place for these types of experiments.
Okay, Dr. Keim and Dr. Fauci, I want to give you an opportunity to respond to the dissent in the letter, which was, I gather, originally a confidential letter and then was leaked, from Michael Osterholm in his criticism of the NSAB decisions, and to some extent, not totally reflected by Dr. Inglesby, but also Dr. Inglesby expressing some concern about the decision. Dr. Keim, why don't you begin?
So first off, on the committee, we are a board of almost 25, highly qualified individuals, and we rarely agree upon anything.
Sounds like Congress.
I know.
Yeah.
And
although we may not be highly qualified.
I must say that we actually embrace this dissent, and we use it, and we actually cherish the different members and their opinions, and it's true for this particular example as well. This was, in fact, a letter that was meant for an internal type of a process for us to understand in a retrospective fashion what we had done and what we'd come through. And as such, it was, I view it as a very constructive type of a communication. It was unfortunate that it was leaked and it became part of the public dialogue. It makes it harder to have a constructive and proactive type conversation there. Many of the things that he said are worth examining. One point that he makes in the letter is in fact that there was a bias in the witness list. I think that that is true. The primary witnesses that we brought in, or briefers that we brought in for this hearing, were in fact the investigators themselves. They're inherently biased. They wanted their work published. We brought in a second investigator who's been collaborating them and working on how you use this information for surveillance purposes. Again, somebody who would like to see their work published and sees the benefits far clearer than the risks. I don't think this is of great concern, though, Mr. Chairman. We are scientists on this board, and what we do is we look at scientific data and look at other scientists' work, and we can be very critical of that. And so the biases that were inherent in those types of witnesses, I think, was not a problem for us. And so we, in fact, I think, dealt with that very well. We were able to ask very tough questions of the investigators over a series of time. Dr. Fauci, for example, was in front of us for 2 hours with lots of intense question and answering about that. So I think that those biases were something the board could deal with quite well. One part that was clearly not was independent of all the other aspects of the science was the intelligence briefing. This was a briefing that was set up by the U.S. government intelligence community. And, we came into that as scientists and pretty much took this on faith that what we were hearing, the assessments of the risks and the political consequences, were fact. That was an environment where the board is perhaps a little bit naive. We don't have the capability to look behind these assessments. The briefing was held at the secret level, and we were only able to ask so many questions, but they were quite confident. And that briefing, in fact, suggested to us that, in fact, the risks were minimal and that the political consequences, again, were great. And I think that had a great effect upon the board. So that's one aspect of Dr. Osterholm's letter that I think, is an attribute of the process itself. This was never set up as a point-counterpoint, so we didn't have time in the 6 hours we had witnesses in front of us to actually have everybody in the world there But the most important witnesses that we did have were inherently biased.
Interesting. So if you had it to do over again, would you try to...
I'd do many things different, Mr. Chairman. One is I would probably make sure that this was a lot of work was being done before it ever came to the board. We were brought these papers, under a very tight timeline back in October.
Right.
And, in retrospect, the amount of time it took and the timeline we're on was much too tight. The process and the number of hours we put into reviewing these two papers was massive. It's clear that the new government policy identifying DIRC early on is going to be critical for moving much of this evaluation earlier on before the board ever sees it.
It's a very important point. I mean, I agree with you that the dissent, even to some extent the bias, is not of itself of concern, particularly in scientific debate and discussion. But obviously, from a Homeland Security point of view, we're concerned about the impact. And am I right that you're essentially, to the best of your ability, providing assurances that information is not going to be released in the two studies, particularly in the Fauci study, that would significantly increase the risk of deliberate or accidental release of modified H5N1?
So the board was pretty confident in the case of the Kawaoka paper and was again unanimous. In the case of the Fauci paper, it was a split vote. The vote was 12-6, and there were strong feelings on both sides. I would say that, again, in this type of a board process, each of us had to weigh the evidence. I mean, there are great uncertainties in this type of research. A very small number, relatively small number of ferrets were actually used in these experiments. So understanding the biological property of these viruses is not 100% certain. We don't know everything there is about these, and so these 20 board members had to weigh the evidence as best they could. And I will tell you, you won't find a better group of people to do this. This board is extremely qualified and able to do this and work very hard at understanding risks and benefits, and came to a split vote on the Fauci paper.
Dr. Fauci, do you want to respond to the Osterholm complaints to some extent to Dr. Inglesby's concerns?
Sure. Well, with regard to the letter, there were, as you probably know, because I'm sure that your staff or you have a copy of the letter, there were several issues that were brought up in there. I have to say that I agree with many of the things that Dr. Keim said, in the sense of this is a strong board, a really good board. We've worked with them for a long time, and I don't think they're going to be significantly influenced by what they might perceive as a bias. So if they did, they believe, as Paul has done in the past, if you have an issue with something, you bring it up. The letter was sent to the executive secretary of the NSABB, who's at the NIH, Dr. Patterson. We have responded on a point-by-point basis to everything in that letter. So we'd be more than happy to make that response available to you so that you could see the point-by-point discussion. Again, there were important issues about looking forward. There were several things in there that I must say, quite frankly, Mr. Chairman, that I actually disagree with. I mean, one of which was the concern about the security briefing. As you know, I have a great deal of trust in the Director of the National Intelligence to tell us what we need to know. So that's just one example. The idea, as you mentioned, about the picking of people who would be on, we did not get any indication from Dr. Osterholm of people that he wanted to see there that weren't there. So rather than go tit for tat on that, I can just say that I think the general principles that were brought up by Dr. Keim, I totally agree with. I just have to say for the record that I disagree with many of the things in his letter.
No, I appreciate that directness, and I thank you for it. Do you have a reaction to Dr. Inglesby's suggestion that the moratorium should be extended? And if so, for how long?
I totally agree with Dr. Inglesby about an extension of the moratorium. The real critical issue is for how long.
Right.
This is a voluntary moratorium, and I think that's something that the public needs to understand. This is a voluntary moratorium on the part of the scientific community.
Right.
I had discussions with the influenza scientists and encouraged them, and they actually, to their credit and to the discussion that Dr. Keim himself had in the NABB, this was something that they agreed upon. Exactly when to call it off, I think we need to see how we can have, and we're very actively involved in pushing forward the principles and the implementation of the March 29th government-wide DIRC policy. That's going to have an important impact on when we can feel comfortable that we can then go on. So as long as people understand both the principles and the implementation mechanisms of how you address DIRC, several of the labs that are involved understand that now. We need to make sure that that's broadly understood. So I definitely agree with that. I just want to make one point of minor disagreement, if you want to call it that, with what my esteemed colleague, Dr. Inglesby, says, that if we only looked at the short-term benefit of research, we wouldn't do a lot of research at the NIH because you very often have a situation where it's incremental and you build up into something that really becomes important. So although I understand the point that's being made, if you look at what immediate benefit of those mutations going to have us right now, sure, you can say that there isn't a lot of surveillance capabilities of high sequencing, et cetera, but the incremental accumulation of knowledge is one of the fundamental principles that the NIH research agenda is built upon. So I think there's a little bit of a disagreement on that. I don't think you need to have an absolute immediate benefit for research not to be ultimately important to do and to publish.
Want to respond? Yes, go ahead, Doug.
Yes, well, I completely agree with what you just said. So I don't think we disagree on that. I agree that fundamental research and understanding biological principles is critical, and it's critical part of the science mission. I think this is just one very specific and rare example where I think the bar for whether to proceed with this line of research should be beyond a deeper fundamental understanding of biology. But in general, I think I completely agree that the test for basic science shouldn't be whether it has practical benefits in the next year. But in this case, there's been a lot of the proponents of the research have been arguing for urgent practical benefit. And in my view, I just haven't seen a compelling case for that.
Not worth it. Yeah, this leads me to ask you, Dr. Fauci, and anybody else who wants to answer. And in some sense, it's a question at the margins. When considering future research that would be seen as DIRC, dual-use research of concern, can you imagine instances in which you would conclude that research should not be undertaken under any circumstances?
I do. I think it would be scientific hubris for scientists to say we can do anything we want to do regardless, just for the curiosity of it, for understanding it. Mm-hmm. So I do think there are some experiments that would better not be done. I think that would be a very rare situation, Mr. Chairman, particularly, I mean, you can fantasize about ridiculous and dangerous experiments just for the sake of doing it. Those we don't even bother with. But in the realm of trying to keep up with something that is a clear and present danger of it happening in nature itself, that's the critical thing that we're dealing with here. And that's the reason why we agree so much on it, and yet we all of us at the table know that this is a delicate issue. If you're doing something in an experimental fashion that you might be pushing the envelope of creating something that would give you some information, but it isn't really addressing any danger, then I think that that's very ill-advised to go there. But when you have a situation where nature itself is already doing some of the things that you're trying to stay ahead of, that's when you really have to seriously consider it. But the short answer to your question, the principles of the new government-wide DIRC policy that we put out on March 29th actually put that into the consideration. So when you look at the number of experiments that you can do, look at there are now 7 classic experiments that if they come up, you have to decide, do you have a risk mitigation for that particular result or that particular experiment? One of the risk mitigations very well may be don't do the experiment. So it really falls very nicely into the answer to your question. It is built into the new government-wide DIRC policy that is, in fact, an option.
So I presume that this is not an area where you can draw a very clear red line, but right? But in other words, what you've described is the standards adopted in the policy, and particularly with regard to risk mitigation, and that in a given case, the decision makers might decide that in the interest of risk mitigation, the research simply should not be conducted.
It's essentially a continual evaluation of risk-benefit.
Right.
And you take each individual case and you look at it, and if it turns out that clearly the risk and our ability to mitigate the risk is such that it's just not worth doing.
Dr. Gerstein, from a Homeland Security point of view, why don't you talk to us a little about this and whether you think that there ought to be clearer red lines here, or whether this is an area of scientific inquiry where it's simply impossible to state a red line unless you see it in a particular proposal for a research project of concern.
Well, Senator, I agree exactly with what Dr. Fauci said. I think there are some experiments that should not be done. In fact, that is actually the intent of the Compliance Review Group,
right,
looking at the NSABB7 experiments and looking at the type pathogens we routinely work with in the sort of threat analysis and characterizations that we do. So we look at these very hard. We make sure that all of them are needed. We make sure that we're doing them in the safest possible ways in the appropriate facilities. But at the end of the day, we recognize that national security, homeland security, needs to look at some of these different capabilities and assess what sort of threats they pose. Still, we're doing them in the highest containment. For the department, we do most of our internal work in our facilities, the Fort Detrick facility, NBAC, and the Plum Island facility, PIADEC. So we're very keen on that.
Okay, we've talked so far about the U.S. government response to this challenge of dual-use research of concern. But obviously, scientific research is global, and in this case, one team in Wisconsin, one team in the Netherlands. So help me understand and the committee understand for the record, what's the state of discussion of standards internationally? Are there international scientific bodies that are moving to adopt standards such as the March 29th U.S. policy, or are different? Are there national standards being adopted in individual countries throughout the world? What's happening? And because obviously we're talking here about a fear, in one sense, of a global pandemic. So if something wrong happens in a laboratory halfway around the world, it could still affect the lives of people here in the U.S.
Yeah, let me take a shot at that, Mr. Chairman.
Please.
You know, it's very interesting because this gets into what we refer to as the culture of responsibility, a global culture of responsibility. Back in the 70s, when the revolution in DNA technology took place globally, but fundamentally here in the United States, scientists got together and tried to develop, you know, it's strikingly similar to the challenges that we're facing now, and came up with what we ultimately have right now, the DNA Recombinant Advisory Committee, the RAC, as it's called. And although that only pertains when you talk specifically about government-funded research here in the United States, what's happened is that the fundamental principles, the codes of conduct, the culture of responsibility that was engendered by the discussions back in the 70s regarding recombinant DNA technology, without any capability of enforcing it globally, essentially permeated the global approach towards recombinant DNA technology. So although we didn't have any enforcement capability, it became something that was widely shared throughout the world. Now, other countries, including the Netherlands right now, are addressing in a very serious manner how they are going to approach this, because it was one of their scientists. But there's also going on in the UK, in France, and places like that. So what we hope and what we envision is that as a result of this, there will be a culture of responsibility that even though we don't have the carrot and the stick of funding and withdrawing funding, that these kinds of principles will actually be implemented throughout the world. We're all hoping for that. and I actually have confidence that it will.
Good. Is Dr. Gerstein, I know that Secretary Napolitano and people in the department now are developing ongoing relations with Homeland Security departments or the comparable departments around the world. Is there discussion of this particular concern in those international meetings?
Senator, there is. We have a number of bilaterals. For example, in S&T, we have 12 nations that we do bilateral discussions with, and we have had these discussions. The nations feel very similar to us, but there is not all good news as far as this is concerned. And I would take you back to the Biological Weapons Convention. Some interesting things come out when you look at that. There's a London-based Verification Research Training and Information Center, VERTIC. And in one analysis they did a couple of years ago, they discovered that very few nations of the 87 that they surveyed even had laws or definitions of what a select agent is. And they didn't have laws against developing, stockpiling, or storing biological material. And the news doesn't get any better when you talk about export control measures. So it highlights the fact that we may be working very hard in this country, and we may put in place the proper provisions. It's important that we do the international outreach, especially into some of the countries that may not have the same sense of the life science issue and the DIRC issue that we do.
Yes, Doctor.
Can I just add to the good news side of the story again? Yeah. First of all, I think the H5N1 debate, as painful as it's been in the last 6 months, has been somewhat useful internationally because people are all paying attention to this issue. So I think that has one good consequence of this has been enlightenment or awakening in many places in the world which weren't paying attention to this. The second point is at a science meeting 2 weeks ago when this question came up, and there was concern that private foundations wouldn't follow the lead of the U.S. government in the new policy, a representative from one of the most important science foundations stood up and said, let me make very clear, if the U.S. government is going to pursue this policy, we absolutely intend to follow it ourselves, and I imagine that others will. And the third point of good news was an article published in Nature magazine yesterday in one of the most important science journals in the world, which said that the U.S. is taking an important leadership position on this DIRC policy and that other nations should follow suit. So there are some indications that maybe this will move in a direction where other people are doing similar things.
Okay, well, that's encouraging. Let me go to a different aspect of the DIRC policy, which interested me, which is that it requires departments and agencies to report to the White House National Security Staff in the next several months on their current DIRC projects and risk mitigation measures. The concern I want to express is that given, put it this way, the National Security Staff is probably larger than most people think, but it's still relatively small for the range and responsibilities it's given, particularly those on the NSC staff that work on biosecurity and bioterrorism issues. And I wonder whether you have a sense of how the information is going to be used to support oversight of such research, and whether any of you expect your agencies and or the NSABB will be asked to support the oversight that the White House National Security Staff is charged with carrying out here. Maybe I'll start with you, Dr. Gerstein.
Well, Senator, that would be somewhat speculative. I would just like to take you back to the deliberations to date. We have used those deliberations to better understand what has gone on with the papers. We've been briefed on the science. We've been briefed on the policies, the issues that have surfaced. And I think what's come out of the 29 March White House-led effort is a good first start. What we expect is that this will continue, that this is not an end point, so to speak, but it is the beginning of a process that we will continue to look and try to ensure that our policies with regard to DIRC are as good as they can be to ensure national security, but also homeland security, as well as ensuring scientific work goes on unfettered. So in that regard, we're very hopeful. It's a reporting requirement. All departments and agencies are submitting to that. and we have not come up with the next step, so to speak, in trying to finalize the policy. I know this has generated, though, incredible discussions across the interagency where departments are getting together and discussing how they're handling it. We received several phone calls to see how we were dealing with our university grants program and the language that we have inserted that provides us at least a stopgap measure should it be necessary to ensure that publication of certain materials would not proceed. So this has actually been a very positive outcome, I think, across the government.
Good. Dr. Keim, do you anticipate that the NSABB may be asked to help the White House in these reviews?
You know, we do whatever the administration asks us to do, and we don't do anything they don't.
Good standard. Thank you for that. Dr. Fauci, do you want to comment on that at all?
I agree with what Dr. Gerstein said. If you look carefully at the DIRC policy, would really the part about within 60 days to give an inventory, within 90 days to determine how you're going to do a risk mitigation, that was really the first cut at making sure we know what's going on right now. I think this is going to be an evolving process. Ultimately, we are going to try and make sure that when you get down to the local level of the institutional biosafety committees, a lot of the kinds of monitorings that will be done will be essentially automatic by well-trained people.
I agree. Let me ask this question. In your testimony, Dr. Fauci, you discuss NIH-funded efforts to develop a universal influenza vaccine, and Dr. Inglesby highlights the ongoing efforts to develop vaccines focused on H5N1. I wonder whether the findings of these kinds of studies will lead NIH and other organizations that fund vaccine research to increase the priority that you're placing on these kinds of research efforts.
The answer is a resounding yes. The situation, there are a couple of ways of getting rid of this problem. One of them, I think Dr. Inglesby mentioned in his testimony, certainly in some discussions we've had, is just kill the chickens that have H5N1 and make sure that we just get rid of the reservoir. That's very difficult to do because you have countries that are not necessarily interested for economic and other reasons. The other thing is to have available countermeasures that actually work and work really very well. And the idea of getting a universal influenza vaccine is not only going to be very important for seasonal influenza, so we don't have to keep chasing each year, getting the right combination and matching it with what is circulating out there, but also is a major, major countermeasure against the emergence of a pandemic. So we are putting a considerable amount of effort, and we've had some very encouraging scientific advances over the past just year and a half to 2 years on understanding much better the type of immune response that you need to induce in an individual to cover virtually all strains. We're not there yet, but this is something that we see the light at the end of the tunnel. It's always risky to predict when you're going to get a vaccine for whatever, but unlike it was a few years ago, we now see that we have the scientific mechanisms and wherewithal that we are on the road to developing a universal flu vaccine.
Well, that's tremendously encouraging, and of course that's exactly the kind of work, even in a budget-constrained atmosphere, that I hope we'll find adequate funds for. Do you want to comment at all on that, Doctor?
I would say that it is extremely encouraging. It's exciting. If we had a universal flu vaccine, it would change the risk equation for everything we've talked about today in the realm of influenza. So I would just strongly support the efforts that are going on at NIH, BARDA, and industry on that.
I have a final question, which is the kind of question, I must say, for the benefit of staff, that my friend and colleague from Delaware, Senator Carper, would normally ask if he were here, which is, incidentally, I've learned a lot from the testimony today, and overall I'm reassured by the government policies that have been put into effect and the decision-making process we have, and even at the far end, that we've set up a process that considers and values risk mitigation and says in some cases it may be that there'll be a decision that research shouldn't proceed because it's impossible to adequately mitigate the risk. So the question Senator Carper would ask, I believe, if he were here, is if you were a member of the committee, and you probably, well, no, I want you to assume that you have the knowledge you have. Is there anything more that we, with our primary concern about Homeland Security, ought to be either asking the government to do or doing ourselves, either by way of encouraging regulation or, in the extreme, some kind of legislation? Dr. Inglesby, why don't you start first?
I don't see at this point any legislative or regulatory proposal that would substantially improve the situation. I do think it's very useful to have oversight like this on the development of the new policy, because I think there are a lot of things along the way that are going to be challenging. I think, for example, understanding the criteria for risk assessment and how we manage those risks is going to be very important. I think the composition and responsibilities of the NSABB will be very important. So asking questions, reasonable questions of government about how this is working as we evolve it is very important. And I think, in particular, paying attention to the very specific case of H5N1 mammalian transmissibility research. I agree that while the decision has been made to move on to publication for this experiment, which I am concerned about, I think the next issue is going to come up relatively soon unless there's a change in course. I think that will come up again, so I think you just have to pay attention to that.
Thank you. Dr. Keim?
So I guess I would reiterate what Tom just said, that the new policy and how it's implemented is going to be very key. One thing that I think was an important role that the NSABB played here is we are a independent body. We're non-government, and I think It's very important that you have external eyes as a part of this new policy. There are inherent conflicts of interest between the funding agencies and the investigators themselves. And what was a unique role that we played in this is we were outside the small influenza research community, and we were independent of the funding agencies, and we're able to look at this in a way that I think is unique, and I think that's an important part of what needs to happen.
I agree. Dr. Gerstein.
Well, thank you, Senator. Well, I go back to the original remarks I made that I think it's a very complex issue. It requires balancing outcomes. We don't want to do something precipitously that's going to have a deleterious effect on the science. On the other hand, we have a very important mission in Homeland Security that we must ensure is well served. We do have to avoid red lines, because the minute you put out a red line, somebody's going to figure out a way to cross it. And so the best way to do it is through very thinking, very judgmental type bodies like the NSABB that has played an extraordinarily important role in getting us through these two papers and understanding what was going on with those papers. So it really does come down to a matter of judgment. On the question of the direct question, do we need legislation right now or regulations? And I would say the executive has a lot of work to do to work through the policies. As we talked about, the 29 March government policy is a first step. We are making great headway. We're continuing those deliberations. We are learning from each other. We think in DHS we've got a lot of good policies that we've got implemented. We're sharing those to the maximum extent possible. So I would like to put down a marker that says that perhaps later, after we've had some more time working through the March 29 and adding more meat to the bones, that we come and consult with Congress on this very critical issue.
That makes sense. I hope you'll do that. Dr. Fauci?
Yes, Mr. Chairman, I don't see any immediate legislative issue that would be appropriate at this point. But I think when you ask if I were on the committee, what would I do? I think what you just did today was really a very important thing. That's really very beneficial to this difficult process that we're going through, particularly with the new policy and trying to get it right and implement it right. And the fact that an important committee like this committee, and with yourself as chair, are actually interested in the subject, are looking at us, and we know that we'll come back to you sometime, and maybe soon, to just give you follow-up about how we're progressing on the implementation of this policy. So you've already done something, I think, that's very important and valuable to us, because not only here in the United States, but globally, people are aware that the United States Senate and this committee is interested in this problem, and that adds a degree of seriousness to it, which we appreciate.
Well, I appreciate you saying that, and that clearly is our intention. So let's agree we'll keep in touch. You know, we want the benefits of scientific inquiry. We need them. we also need to mitigate risk. And I think the policy that we have now is clearly aimed at doing exactly that. So we'll follow it to see how it's going. Maybe we'll come back again and do one more hearing toward the end of the year. But I thank you very much for the work you did on your prepared testimony, which will be entered into the record of the hearing, and for the testimony this morning. We're going to leave the record of the hearing open for 15 days for any additional questions or statements. With that, I thank you very much, and the hearing is adjourned.